Hello everyone, this is Daniel Smiley and we're going to talk about SYZ parameter analysis today. We have an example that we're going to uh, show you. So I'll start with the content. That's checking the nets and details. Then we talk about net base, the how we set up the port. Then identifying differential nets. We generate the ports and the analysis and the result. So at the beginning, we need to check the nets and the details of the PCB board. So SIwave is the software that we're using for this study. That's why SIwave has a validation check that is available in software. So once we hit that, it goes through lots of details of the PCB and then check the details. And if there is any error, it'll show it to you. As you can see, there are some error like disjoint net or floating node error, and it fixed some of them, and it may not fix some others. The software, we can use the software and fix as much as we can with the auto fixing, and then after that, we can do fixes manually. So that's what we can do for your PCBs. And then once that is done, we run it again, and you see this time there is no problem, there is no error in the system. So that's why we recommend checking a couple times, like once after the auto fix and manual fix is done, then check again to make sure there is no error. This is the board that we're going to study today. Uh, uh, so we showed the different view of the board here. So we chose two different nets. One of them is shortened, and one of them is small net, a T-shape and a continuous net here. And that is what we're going to study today and plot the SYZ parameter on them. So once we do that, another step is to make sure we identify the differential nets, extended net, and power and ground net. I showed differential net an example here. So as you see in the left-hand side, there is not differential pair. But once we do the auto identify, we'll see a bunch of differential nets here. The key point is that to understand how to do the auto identify. Usually, the nets are followed by some suffix, for instance, underline P, underline N. So this is a pair. There could be other suffix that we can use. For instance, in this case, there was no P and N. It was only underline. So we need to study the nets and see what can distinguish the plus and minus pairs and use that. And once we do that, we just put auto identify, and then the software does the job for us. We can also try extended net and make sure the power and ground is correct. So once we do that, then we go to generate ports. We need ports because we need to measure the SYZ parameter there. So in order to generate ports, we have three ways to do that. One is generate ports on selected nets. That means that we choose some nets, and as you can see here, there is no port. There is it's empty. So we choose some nets, and then with the help of the software, we generate some ports, which is use of this part, generate ports on selected nets. And as you can see right now here, there are a list of ports here that were added to the software. Another way is that generate port on selected components. So we go and select some components, whatever you are interested in, and we choose some ports on them. Another one is doing manually, meaning, for instance, you want to have a port within these two. You just need to grab the port generator here, and then put one leg on the left-hand side, and one leg on the right-hand side, and then you can put the port there. So there are three ways. We're just showing one of them here. So once we generate those ports, we are going to run the SYZ parameter. As you see, we ran it here, and we're showing you the results. You can choose any of these nets here that's connected to your port, and then once you hit on it, I'll show it to you in a second, then you'll see the result here. Another cool point is that we can plot this in also electronic desktop. So I'm going to show you the software and the result in software. So here, very quickly, I'll show you the result. As you can see, we can plot the magnitude, and once you add, for instance, you can add a curve here. And in order to better see this, we need to make sure. Give me a second, please. There's a problem with the remote access that I have. Okay, this should fix it. So once we do that, we can change the scaling, because right now it's linear. We change it to logarithmic. I just put it on linear so you can see the difference. And here it shows the S parameter for this range of frequencies. We can add more parameters if you want. And then on the downside, you can see Y parameters. I already changed it to logarithmic. As you can see, we can also change the Y scaling to logarithmic, as well as the X scaling. And now we see the difference. So this is the Y parameter. We can also check the Z parameter if you want. We need to change that to same to the logarithmic. So here with this approach, we can understand S, Y, and Z parameter, and study the circuit and see which one is not aligned with the design, and then start changing them. As I mentioned, a cool thing is that we can plot this in electronic desktop, which I already did it. And by the way, this is not in logarithmic yet. If you want, we can do the same here, change the scaling. But that is the interesting part about the SYZ parameter. We can change it to electronic desktop and also do some calculation or with it. I hope you found this useful, and just at the end, I'm going to show the circuit board to you, so you have a feeling of what we were dealing with. If you have any question or you have any comment, please let us know. And here you can see the ports that are aligned here.